Buoyancy is the idea that objects will float in water, depending on their density. And when you put something in water, there is actually a force acting upwards to push it up. The buoyancy force that water provides on an object pushing upwards is given by the formula rho Vg. Rho is the density of the liquid. V, very importantly, is the volume of the object, and G is the gravitational constant. So let's imagine there's a tank of water and there's a block submerged in that tank of water. What we have to think about is that this block is displacing water. There's water that wants to be there, and the block is kind of pushing it around and pushing it aside. And it's this displacement of water that's creating a buoyancy force upwards. The volume of the water is the same as the volume. The key idea is that the volume of water displaced is the same as the volume of the block. There's actually a great story about this. One of the great figures from the ancient history of thinking about math is a guy called Archimedes. Archimedes was known by his king to be one of the smartest people in the world. And somebody came to the king and gave them a gift. And they gave them a statue and said that this statue was pure gold. The king was very impressed by the gift, but suspected that the gift was not pure gold. And he wanted to know if it was pure gold or not. And he said, Archimedes, I want you to tell me for certain whether this object is gold or it is not gold. Now, those Greeks were pretty smart. They actually understood about density and knew the density of gold. The Greeks knew a version of the rho equals m over v formula. So Archimedes knew that if there was a golden statue, if he could get the mass and get the volume, then he would be able to figure out the density. The density of gold is 19,320 kilograms per meters cubed. So if there are other things mixed into the gold, it will have a different density. So Archimedes was able to weigh this statue, but his problem was he didn't know the volume. I don't know what the statue looked like. Let's imagine it looked like this little thing. So basically, the king was saying, tell me if this is gold or not. And Archimedes was saying, I don't know how to exactly measure the volume of this guy. So Archimedes spent the whole week stressed out about how to figure the volume of this. So during that week, he got into a bath, and the bath was totally full with water to the top. And as he sat in the bath, some of the water spilled over the sides, and he realized that the volume of his body was displacing the volume of the water, and that the amount of water that came out would be equal to the amount of volume that his body had. That is, he figured out this principle of displacement. When you put an object into water, it displaces it upwards. And so he knew that he could be able to figure out whether this thing was gold or not. And he jumped out of the bath, totally naked, and ran down the street yelling Eureka, which in Greek means I have found it. That is, I found the answer. So the principle of displacement's like this. If I have a tank of water and the height of the water is like that, I then throw in a block. So this new height for the water, that little disc there will have a certain volume. The volume of that disc will be exactly equal to the volume of the block there, because the block is displacing the water. Okay, so this water that's being displaced causes an upwards force. Let's say that this block has 0.5 meters all sides, it's a cube of 0.5, and it's in water. What will the force of buoyancy going upwards be? The volume of the block will be 0.5 cubed. So we just plug all these numbers with the density of water at 1,000 into this, and the force of buoyancy will be 1,250 newtons upwards. If we think about a block suspended in water, we could think about a free body diagram of forces. So this block will only have two forces, a buoyancy force going upwards and a gravity force going downwards. So for this block, we don't know what the gravity force is because I didn't tell you the mass, but we know that the buoyancy force will be upwards. So one way to think about floating and sinking is if the gravity force is much larger than the buoyancy force, it's going to sink. And if the buoyancy force is larger than the gravity force, then it's going to float upwards. We can actually use this thinking to figure out how deep something will be in the water. The best way to improve your grade is with practice tests. I have a free practice test on my site. Click the link below to get your copy, and we'll even mark it for free. Let's imagine this same block, which is 0.5 meters cubed, is floating in the water. Let's say the mass is 30 kilograms. We can figure out from this information how deep the block will be in the water, how much it'll be floating in the water. We think about the free body diagram, and we want to say this is going to float when these forces are in balance. So the deeper it is, the larger the buoyancy force is going to be. A greater volume of water is displaced. So this block is going to find naturally the point exactly where the buoyancy force and gravity force are going to meet. And that's going to be the suspension point where the block floats. Let's figure that out. We want to get so that the force of gravity is equal to the buoyancy force. What's interesting is that gravity actually cancels out. So this is saying the mass of the block equals rho v, but that's actually just saying the mass of the water that's displaced. Anyways, so we can calculate the volume of water that's going to be displaced from this formula. So the volume is going to be 30 divided by 1,000. Okay, 0.03 meters cubed. We're not quite there though, because we're trying to figure out how deep this block will be in the water. What's the height there? So we just got to think about the volume. It's going to be like a little square. And the volume of this little kind of box there that's under the water will be that area of the square underneath times the height. So this is like the bottom of the box, and that's the height of the box that's under the water. So we just say this volume of displacement should be equal to this. So I get h is 0.03 divided by 0.25, and I get the height is 0.12 meters. Remember, this was going to be 50 centimeters high, 12 centimeters. So it's about a third of it is in the water. So that kind of feels a bit right. So what we did was we just said that the force of gravity is equal to the buoyancy force to figure out the height of that guy there. Just want you to notice the units here. That's a volume that has meters cubed. And that's an area with meters squared. So the units of this are height, meters, meters cubed divided by meters squared. So we've been talking about buoyancy. I wonder, do you float or sink in water? Is your buoyancy force larger than your gravity force? Write your comment below about your experience of floating in water.